Hello, guys. Welcome to another episode of Cuda Education. Today, we want to briefly cover the concept of the depth buffer. Okay, so the depth buffer is basically the mechanism by which the camera or the application, I should say, the application decides um, what objects to draw and what objects not to draw in relation to the distance to the camera. Let me repeat. Every object is a specific distance away from the camera, and the application has to decide, do you draw an object um, or not draw an object? And you want to decide, the deciding factor is how far, A, how far away is it from the camera? And B, is there an object closer to the camera that's going to block the object that you're considering? So, A, how far away is it from the camera? Let's say it's within the range of what we want the camera, of what we want to render distance wise from the camera. So yes, it is within range, but B, it is not the closest object to the camera within that region. Okay, so yes, the object itself is within the range, the distance from the camera. It checks that box, but it doesn't check the box of, is it the closest object to the camera for that particular pixel or particular region. Okay, so this is all sort of the responsibility of the this is all the responsibility of what they call the depth buffer. Okay, so the depth buffer basically decides, you know, is it are we going to see the object? Is the object going to be drawn, right? And of course things are drawn um on the GPU by the GPU and stuff. The command might come from the CPU and all that, but the object is actually drawn on the GPU, right? So we have to decide, you know, are we going to draw the object? So for example, if we turn here, this wall right here, this wall and the lantern and the tree and the plants and stuff, this is the closest thing to the camera. So guess what? The application is going to draw the wall, it's going to draw the tree, the plants, the light, whatever. And it's not necessarily going to draw anything behind it because it doesn't want to use up resources, right? So, as far as we're concerned, everything looks totally fine. We have this wall right here of the building, the side wall, the front wall, or whichever wall you wanna consider it to be. It's being drawn, but everything else behind it isn't being drawn. Okay? Because we're in the business of saving compute and saving resources and saving energy and saving the planet and all that good stuff, right? So we're not gonna unnecessarily draw stuff that's not visible. Okay. And this logic is basically the responsibility of the depth buffer. Okay. Now, the other thing that you guys have to understand, and this is something I learned early on in my endeavor with computer graphics, is that um, the sensor or the realm of the camera, it's not literally like a wall, right? Like a vertical wall, and then you have rays shooting out of it. So for example, let's say we're dealing with this side wall here. Forget about the awnings and this red stuff, but we have this side wall here. Okay, the camera is not like a tall wall. It's not just like a wall and then you're shooting rays from the wall in order to sort of count distance and visibility and all that stuff. That's not what a camera is. Okay, a camera is not a wall, a vertical wall with horizontal rays shooting away from it. What a camera is, and sort of the sensor that is used to decide what is visible, not visible, and the realm, the domain of what the camera sees and not. It's actually a point, and then you have rays basically shooting out from that point in a three-dimensional manner. So there is a saying that says equidistant rays from a point in world space, in 3D space, creates sort of a sphere. Okay, so we have a three-dimensional sphere, you could say a three-dimensional circle, right? And basically the domain of the camera, what the camera sees, and the deciding factor for whether something, whether it's seen by the camera or not, is based on, is the object within the sphere or is it not within the sphere? If it's not within the sphere, then obviously we don't see it. If it's within the sphere, then we see it. Okay, so that is sort of the mental model of how you think of a camera. We have a point, and then we have equidistant rays that shoot from that point. Now you get to decide, as the application developer, how far off into the world space you want your rays to be. How far off you want your rays to be. How far off you want your rays to be shot into the world space. But that's only half of the conversation. The other half is okay, the object is within the sphere, so we should be able to see it, but do you have another closer object that is blocking visibility of the object that you're considering, right? And if you have another object that's closer, that closer object takes priority, just like in our example here, right? This wall is going to take priority from any and everything that's happening behind this wall, right? Now, this wall is part of a building, whatever, and even this curtain. So this curtain is going to take priority over everything else that's happening behind this curtain. And we're only going to see the curtain because the curtain is the closest thing to the camera at this pixel, at this point in world space that we see. Okay? So again, is the object within the range of the rays that we're shooting out into the scene? And then B, is there a closer object that obscures the visibility of the object behind it? Okay, so for example, even like this tree right here, this plant, this tree, right? This is the closest thing to the camera at this pixel at this point. Okay, so we're not going to see what is behind the tree because these pixels here are the closest thing to the camera. Okay, so we save the processing for everything behind this tree. Now, there might be little peepholes and stuff in the tree, which is another consideration, but only what is visible, the closest thing to the camera is what's visible, and everything else gets, obscured. And we save the processing for that. So, today what I want to do is just focus on these rays. So we have a near plane and we have a far plane. Now, what happens is that when we play around with the distance of these rays and basically tell the application, okay, we want this specific window or this specific range to be valid objects and everything else to not be. Okay, so let us start with, we have the near plane of 0.1 f, and we have the far plane of 100 f. Okay, now these units, it's not like centimeters or meters or inches or anything like that. It is sort of a world unit that is not necessarily something conducive to, what we would normally measure. But basically, it's adjusted for the units of the scene, okay? So what we're going to do is we have 0.1 f to 100 f. What we're going to do is we're going to say, okay, the near stuff stays near, and we're going to see those objects, but we're going to cut how far out the depth buffer validates objects and therefore draws objects. Okay, so we're going to cut it. We had it at 100, and now we're going to go to 10. So let us see what happens when we tinker with this specific value. Okay, so when we tinker with this specific value, we're going to see now that everything past 10f is no longer valid. Okay, but notice how the contour of when things get to pass the validation, notice that the contour is sort of, it's not like appear and disappear. It's sort of like, you're almost like looking at the sensor is almost like a circle. So you could see how the behavior of what gets validated is basically, the sensor is basically a sphere. So as I move further in, notice that it's not like everything at this point right here gets seen. It's sort of like this gets seen because it's a straight line from the point, but then a lot of things around it are blacked out, and that makes sense with a sphere, because a sphere, if this is the furthest, let's say, x distance, displacement from the camera, we're going to see the lamppost, but everything around it or beside it we don't necessarily see, because our world space is a sphere. So as we get deeper and deeper, notice that we start to see more and more, but the behavior of what we get to see and what is validated and not validated is that of a sphere. Okay, so this is what the depth buffer does. Okay, and when we go around, we see that we get this behavior. Now, let us play around with it a little bit more. So, let's make this 10 and make this 1. Let's flip the script. And I don't know if this might not be wise, but we'll see what happens. Yeah, this doesn't, let's not do that. Let's just play around with it some more. So we're going to do this at 10, and we're going to do this at 20. So near plane is 10.1, far plane is 20. And we're going to see how this all plays out. So notice now, what is very close to us we don't see, right? But then what is far away from us we do see. So we invalidate. So literally we're literally looking through the building, right? So we're literally looking through the building. everything too close to us is not seen. Now the sky is a different thing. The sky, whatever, right? But you guys can see that now there is a different, a different behavior. And if we get more aggressive, where we do 20 here and we do 30 here, we're gonna see we're gonna see even further into the distance, but everything closer to us disappears. So the things way down here we see, the things inside of the building we see, but everything close to us we don't see. You see? Everything close to us we don't see. You see? So that is a function of the depth buffer. Now we have to appreciate, so let's just put everything back to normal. We have to appreciate, where is this all being decided? Okay, so we're in renderer, APL renderer, load assets function. Okay, so the renderer, APL renderer, and the load assets function. Okay, so this is sort of where we get to see where all of this stuff is decided. Okay, and while we're loading the assets, we're deciding, what's the behavior of the camera, what is seen and not seen. Okay. Now I haven't actually played around with view angles, so let us just run the application first, like it normally runs, and then we'll play around with the view angle to see if we see some other behavior. So we have our normal application, right, guys? Nothing crazy here. We have our normal application. Okay, now let us mess around with the view angle and see what that does. So the view angle does, what is it doing? It is it's like we got to step back, guys. Like, what's going on here? Anyway, we'll have to investigate this some more. I don't want to even, what I thought it would have been, it's actually not. But that's all right. Okay, I have good news for you, Mac Neo guys. Mac Neo guys. I know you're the coolest kids on the block now. You Mac Neo, MacBook Neo. Okay, MacBook Neo guys. There is good news. There is good news. Yes, good news. Cuda Education brings good news. The good news is that for you MacBook Neo guys, you will be able to run these you'll be able to run Metal 4 on MacBook Neo. Okay, you will be able to run these applications on your MacBook Neo. Okay, so this is a Metal 4 application, which is the latest the graphics API from Apple. Okay, so Apple Metal, but this is the Metal 4. So if you have a MacBook Neo, you will be able to run this application. MacBook Neo is able to run Metal 4. Okay, so in order to run Metal 4, you do need Apple Silicon. You could look it up for the specs and stuff in terms of which and which, but I believe all of the Apple Silicon stuff can run Metal 4. But look it up before you make any major purchases. But the MacBook Neo can run Metal 4, which means you can run this application. Okay, and I have links and stuff down below. This application is freely available. So if you are artistically inclined, if you are interested in computer graphics, if you want to prepare yourself for the new world, for the new era, all of this stuff matters. Okay, so follow along, like, subscribe, all that good stuff. And, let us learn Apple Metal in 2026. We're already basically done with the first quarter. Got 3 more quarters to go. Let us make sure at the end of 2026 we could say that we know a lot about Apple Metal. So anyway, guys, I don't want to make this video any longer. But if you know anyone that's artistically inclined, if you know anyone that might be interested in programming, might be interested in computer graphics, this is the place to be. Let's just mess around with this view angle thing one more time and see what we get. So we're further out. Basically, everything is now compressed. But anyway, I'll do another video for that. Let me make sure that I am back to baseline. So we're back to baseline. All right, guys, thank you for watching. You could download this application. We're using the links below. Like, subscribe, tell your friends. Let's build a community. Comment if you have any, comments or questions or whatever. This stuff is pretty easy to get installed and running on your machine, assuming you're able to run Apple Metal 4. Thank you guys for watching. Have a great day.